Good morning, science friends. I hope that you're having a good week. I know we're still at home and we're still staying safe, and you notice that I've changed locations today. So it's officially spring break for one of my children, and my other child who was on spring break is now doing his college work. So I've shut the door so they can't interrupt me and I can't interrupt them at all. So I thought it'd be really fun to talk about, and you can try at home some fun things that have to do with magnets. Now, magnets are around everywhere and they're very, very useful, but let's understand how they work first. So, magnets are usually made of metal, right? There's no plastic that is metal, that is magnetic. And when we try to put our magnet to something plastic, it's not going to work. But not strong enough to hold it. If I were to put it with something metal that's smaller, it was strong enough to hold the paper clip because inside the paper clip is metal. Now, there are three main metals that are magnetic. Not all metals are magnetic, so not all doors are magnetic, and it depends on what type of metal is in it. So there is iron, nickel, and cobalt. Those three metals make something magnetic. And how does this work? I like to think of it and explain it because we are a Star Wars family and we love Star Wars. So we have always thought about the Force and having the power of the Force to be able to do things. So if you were to take something, and you can try this, I'm going to use a plate, right? I'm going to put one of my magnets on top of the plate, and I'm going to use a different magnet below the plate. They're sticking together. And I'm going to see if I can move the magnet. And all I'm doing, as you can see, is I'm just moving it around the plate. But even through the plate, my metals are sticking together. Okay? So, magnets like to be together. So let's understand how that works. Magnets work, and if you have a bar magnet, I don't know that you'll have this at home, but if you have a bar magnet, you can see there's an N, and I have a boo-boo on my finger. From all this hand sanitizer drying out, I'm getting hangnails. An N and an S, right? N and S. So let's think about an N and an S as we do this. So the magnets have two areas that are important to understand. And I'm going to draw a little drawing. So just like my bar magnet that I showed you, they have an N and an S, right? So the N stands for North Pole. We've heard that word before, north seeking pole. So it's looking for its North Pole, right? And the S, what do you think the S stands for? South Pole. So, and what happens is the flow of this force, this Star Wars force, this magnetic field, is always north to south. So if I were to draw that, and it's very hard to see, very, very difficult to see, but if I were to draw that, you would have arrows representing my magnetic field going from north to south, not only between the north and south, but everywhere out of the North Pole. We're getting these arrows out like this. See that N with all the force pushing out? And that S would bringing it all in. So we have North and South poles. And it kind of looks like this. So they are attracted together because the north is pushing away and the south is pulling together. So let's see what happens. I actually have two magnets here. They are magnetic. And I don't know that if you can see. Do you see that N right there on the yellow side? And on the S side, I've got the S. So if I were to try to put two north sides together, two N's. So I've got an N here and I've got an N there. So two north sides. I'm going to try to put them together. Oh, I cannot. And they kind of want to move. They do not want to be together. That is called repulsion. Can you guys say that? Repulsion. That's a tricky word to say. So I'm going to write that down. repulsion. And that means it's a push. Repulsion. Repulsion. They do not want to be together in any way. Repulsion. Okay? So, like I was showing you, the two northerns do not want to be together. You can see them fighting to push away and not want to be together. It's almost like the force that maybe Rey would use or something from the Star Wars movie, which is so cool. So the other thing to consider is what would happen if I put an S with an S. So again, two like magnet poles. I'm going to try to put them together too. Let's see what happens. So I got my two S's going together. Oh gosh, the same thing is happening. So the two like poles do not want to be together. And the way that you can try this at home, if you don't have magnets like this or even a bar magnet, a lot of times kids have around, you might have Thomas trains that connect or any kind of toy that connect through magnets. If you change the orientation of how they, instead of having them connect and click, if you change the connection of one side, you would feel that repel, that they're pushing away from each other. So let's see what would happen if I would change one of them so that I have opposite poles. So let's say I do an S and let's do an N. So what do you think is going to happen when I do an S and an N? Oh my gosh, I can feel it right there. Did you see it jump out of my hand? An N and an S want to be together. That's that pull together. That's that field working to snatch it together. So that is called attraction. Can you say attraction? Attraction. And you might have heard that click, that snap. Attraction in red. Attraction. That's that click, and they want to be together. Now, I don't get that with my S to S, and I don't get that with my N to N. But if I switched one side and I have opposites of going together, an N and an S or an S and an N wanting to be together, you'll get that attraction and that click. If it's a metal and if there's iron, nickel, and cobalt in it, this is where we get tricky. So we've talked about attraction and repulsion. We've talked about the north to south flow. Let's talk about another cool thing about magnets. Now, when I was talking about magnets, I might have mentioned, I mentioned, a north pole and a south pole. Now, Miss Erin does her drawings, and a lot of my science friends recognize things when I draw them because Miss Erin is not a good artist. But I like to draw things to help explain. And the only way this is going to work by you knowing what I'm drawing is to be sure that you have your imagination on today. Do you have your imagination on today? Did you wake up and get excited about the day not knowing there would be a video here? If you don't have it on, let's go and make sure we have our imaginations on today. So be sure you've got your imagination on because my drawings are not great, but I need you to know what it is. I need you to be able to tell me what you think it is. Are you ready? What do you think this is? Miss Erin. This is Miss Erin's drawing of Earth, where we live. Now, it's not perfect, but I think you kind of can see it. What do you think the blue is in this picture? Right? Water, oceans, things like that. And what do you think the green part is? Life, plants, ground, grasses. So this is a general idea of what Earth looks like. Now, when we were talking about magnets, we talked about a North Pole. Do we have a North Pole? We do. Who lives at the North Pole? Somebody that might visit you during December. But we also have some animal friends called polar bears that live on the North Pole. It's up on the top. And then we also have a South Pole. And who lives at the South Pole? My animal friends, the penguins, live at the South Pole. So, we have a North Pole and we have a South Pole. Does that look familiar? Look at that. My bar magnet with its north and south is the same as a north and south poles on Earth. So if I were to just complete the drawing and put the bar magnet in there, you can see that the largest magnet in Earth is Earth. Earth is used as a magnet because a lot of times inside Earth, and many of my friends that we've had volcano lessons have learned about magma inside, that river of fire inside the Earth that has a lot of iron and nickel in it and cobalt in that river of fire. So it's magnetic. So how do we use magnets to use this power of Earth, the force that Earth has? So a lot of times, and some people might be familiar with something like this. Anybody know what that is? It's called a compass. And it uses the power of Earth's magnet, the field, the force around Earth, to help give you direction. Now, do you see if I turn it, the little red dot stays. And I know that that should always be pointed at north, like catching up like that, okay? So that means if I'm out in the middle of the ocean and I don't know which way to go, I could pull out a magnet. And the little red dot would tell me, based on showing me where north is, let's see if it'll find it. I need to make that land on north. There we go. So then I would know which direction is north. That's one way we use it. Airplanes up in the sky, there are no roads up there. How do they know where they're going? Boats out in the oceans, there's no roads. How do they know if they want to go to the North Pole and see the polar bears, or the South Pole and see the penguins? They might use something like a compass, right? We can change it by even using a magnet to move it even more, right? So compasses are very cool. Sometimes you might have a refrigerator that you can put pictures up on the outside using magnets. And I want you to try this today. Try to open your refrigerator door and then try to close it. But don't close it all the way. Put it about right there and watch what happens. The refrigerator has a magnet in it to keep it closed, to keep the cold air inside the refrigerator. So we use magnets a lot. They're used in everyday life. They're also used in computers to help the drive and memory work. They're used in hospitals with MRIs and healthcare and keeping people healthy. So magnets are cool and magnets are important. And I think they're super because they use the force. So I'm going to leave you with a couple of things that you can try today that have to do with magnets. All right. Now, I don't happen to have any, but if you happen to have any total cereal is known to have a high percentage of iron in it, and iron can be picked up by the magnet, and we can show you how it works. You can actually see the iron in the cereal. It has the highest percentage of iron. So if you take a little total cereal and you put it in a baggie with a little bit of water and it gets mushy, like you make a mush of it. If you take a magnet when you're done and it's mushy and you run the magnet through it over and over and over, you might be able to pull out some little flecks of dark iron that you could see, separate it from the cereal. Now there are YouTube videos and pictures of this that are easier to see. I don't have any access to it right now, so I can't do it with you, but it is a very cool visual experiment. It's not a huge difference, but you can see tiny flecks of iron. Another thing I want to do with you is I want you, if you can find a magnet around your house, I want you to go and test things on your house. Doorknobs, doors, light switches, power switches, even, you could even try scissors. Plastic, so we know it's not going to work. Metal, look, that is working. Wonder if my race car would be magnetic. Some of them are. They might have metal parts, but they might not be iron, nickel, cobalt. So go around your house and take a magnet that you can find in your house and see if you can find something that it'll stick to. These are cool things to experiment with and see. Make a prediction that if it's metal or not metal, first of all, you have to determine that. So if it's metal, it has a chance. If it's not metal, like wood or plastic or paper, it's not going to work. A leaf, not going to work. A feather, not going to work. But if you had something metal that had iron, nickel, or cobalt in it, it's going to be magnetic. A lot of doors these days are metal. File cabinets are metal. Here's a file cabinet sound. Did you hear that? That was me putting it on a file cabinet. So you heard that click, that attraction that brought it together. The other time that we need to talk about magnets, and the other thing that goes along with magnets, is static electricity. And a lot of times static electricity is very cool because it uses the same kind of concept. It uses an attraction of something wanting to be together. And I'm going to talk to you about static electricity and leave you with a little experiment. But one of the ways we see static electricity is with lightning. So lightning comes from those clouds that we've talked about. They get charged up with that negative charge, and their energy wants to be with the ground. So it makes a bridge from that cloud to the ground for that split second and allows that lightning, that power, to be there. So we have to be very careful about lightning, and that's another reason why we need to go inside for lightning. But let me show you my magic salt and pepper experiment that you could do and try to get some static magic. All right, so here's what you need. You need the paper plate, you need salt and pepper, you need a rag that's just a little damp, and I like to use a plastic spoon. If you have white, that will work, but a color or clear is great too. You can also try a straw. Don't get new straws, just use old straws. All right, so what you do is you take your salt and pepper and you put some on your plate. I had a bunch in the bag, so I just used that. So you can see in the bag, I put it on the plate, all right? So I've got my salt and pepper on my plate there, right? So I want to make sure that there's no magic in my spoon right now. So I'm going to clean my spoon, make sure there's no magic in there. Now that I've put the salt and pepper together, you need to find a way that you can separate the salt and pepper. Now this is pretty tricky because I cleaned it off, there's no magic. So I'm just gonna wave the wand, make sure you can see this, over the salt and pepper. And nothing has happened with the salt and pepper. Nothing has happened. All right, so now we're going to see if we can catch that magic and try to pull off some of that pepper. Now, both of salt and pepper are positive, but one is lighter than the other. So one is going to jump better than the other. We might get some of the other one, but the majority of it will be only pepper. So you're going to charge up your spoon, and I like to think of this like sometimes when I take off my sweatshirt, I have wild hair. That's why I always keep it up. And when you use the power of your hair to charge it up, I'm putting that charge like lightning in a cloud. I've charged it up. I can't see anything on there, but I'm firing it up. Sometimes when I take off my sweatshirt or my shirt, my hair likes to stand up. Or if I shuffle my feet on my shag carpet and then I touch somebody, I might shock you, right? So you have to think about ways that happens. And then, so I've charged up my spoon. I'm going to take it over my plate. See, wave it over and see what happens. Can you see on there? I have picked up some of that pepper. It has jumped up onto my charged spoon. So you can try different items. I'm going to try the white spoon. Let's charge it up and see what happens. I might not be very good at getting power today because I washed my hair this morning. So let's try it again. Oh, I heard it that time. I can hear it jumping. Oh my goodness. Can you see all the pepper that jumped up on my spoon? So this is a great little magic trick for you to try that has to deal with static electricity. My hair is very staticky now. Okay, so it's similar to the magnet, right? So I want you to try that. So explore your house with a magnet. If you have pipe cleaners and an empty 2-liter or something like that, you can cut up the pipe cleaners and put them inside, put the lid on the 2-liter, and run the magnet outside the 2-liter and move the pipe cleaners around, and you'll see the magnetic field make the pipe cleaners stand up. explore with the Force, and do a magic trick for Mom and Dad. Let me know how it goes, and I look forward to seeing you next time, friends. Have a great day. Bye.